great questions. Nope. The most common missed question, somewhat understandable. You'll see it again. Responses. Actual weight. So this question, it was the last one, okay? And again, somewhat understandable because I gave you a graph that we haven't talked about yet because this is actually came from the second part. So this, I mean, I understand this part, but I want you to make sure you know how to do it. That you didn't just guess, because when you guess, right, and you get it right, it says, good job. Doesn't help you any, right? So in this problem, what they have done is says a study to gain nutrition developed country, yada, yada, yada. Researchers got a mean weight of 170 during the month, yada, yada, yada. Here's the equation of the line of best fit. That's the equation of the line of best fit. Now, this is not the scatter plot of that data. This is a scatter plot of the residuals. And we'll talk about that. That's one of our first things we're going to talk about today. So like I said, I kind of understand that because we didn't talk about a residual plot. We talk about scatter plots, but not a residual plot. But you guys are freaking brilliant, so I thought maybe we could kind of somewhat tie this in. Here's the age in months down here at the bottom, and then this is the residual on this side as opposed to the actual Y value, okay? And so you can see that there's a residual of almost 0 right there. That must mean at that point is darn near on that line, right? That's what, if there's a residual 0. These points here are above the line, and then these points here are below the line, okay? Well, they wanted to look at, use the equation of the least squares regression line and the residual plot to estimate the actual mean weight when they are 1 month old. So when they are 1 month old, that comes right here, that's that dot right there, okay? And this is going to have to be a little bit of estimation because we don't know exactly what that number is over here, right? But you guys do know that the residual is equal to the actual minus the predicted, or it's y minus y hat, or whichever way you want to do that, okay? So what I'm going to do is plug in 1 into that equation and get weight hat, which is y hat. That's my predicted. I don't know the actual, because that's what they asked for, but I know the residual because the residual over here looks like it's something like maybe, I don't know, negative 0.9, negative 0.8. And so luckily we got some choices over here. Well, actually, they're telling me how to find it. They don't actually ask for that, but they got 0.85. So it must be 0.85. So this is 0.85, and you guys learned, I don't know, pre-algebra, how to solve a one-step equation. Move this side to the other side, good. So you're going to add the 0.85, or sorry, it's going to be 0.85 plus whatever this plugged in was. And so my guess is, well, whatever it was when you plugged it in, it's either this one or this one. Fair enough with that? So I popped this one on tonight's question also just to make sure that it wasn't a big issue. So I should see 100% on this one this time. That makes sense? So good. I also popped a question from 3.1 on there that you guys should do well on. I figured out how to pop the old questions back on the new stuff. And when it's an old question that you might see again, I thought, man, I could just start kind of reteaching that or relearning. Anyway, yippee yo. What do I do on this? Delete. Ha! That's what does it. Okay. Rest of those we're okay with. Beautiful. Let's finish my notes today. Let's finish today. I'm going to give you a bunch of stuff. I can't believe they do all this in one lesson. Non-blocked class. I don't see how that's possible. So here we go with today's. First thing we're going to do is jump right into those residual plots. Okay, residual plots. So a residual plot is a scatter plot that plots the residuals versus the explanatory or the X. And it's just exactly what you just saw, right? You'll see an X down here in the bottom, and then you'll see the residual. Now, one of the few times you're not going to see like quadrant 1, you're going to see quadrants 1 and quadrants 4. You're going to see quadrants 1 and quadrants 4 because residuals have both what? Positives and negatives, right? And so that's why that residual plot kind of looks like that, because this is the x-axis. And the x-axis will almost, no, it won't almost, it should always go right through the middle of those plots, because you have the negatives and the positives, and they should line up something to where you get the sum of 0. Okay, with good? So it should always go right through the middle. If it doesn't go right through the middle, you do not have the line of best fit. Okay? I mean, if you got a bunch of extra ones up here, that means you're under predicting too much and you're not doing a good job. I mean, we just don't have the line of best fit. You don't have the LSRL. Okay? So that's what a residual plot is. Here's the actual plot. This is going back to my trucks, the 16 trucks. This is my actual plot. Okay? So picture this. This is now going to be my x-axis. And I'm just going to pivot that thing down. And so these are going to be the positive residuals. These are going to be the negative residuals. Fair enough? So this is kind of going to be my x-axis when I pivot it down. Good? That's the residual plot. Okay? So from the residual plot, you should be able to find the residuals. And if you find the residuals and you have the predicted, you can find the actuals, or vice versa. Okay? But we can see, even from the residual plot, that now this one looks like the worst one. That's predicted the worst one. That's the biggest positive residual. This may be tied. Biggest negative residual may be tied. You can see by far that this one is now easily the smallest residual. Again, I could see it over there, but this amplifies it. This amplifies it. Okay? Everybody okay with residual plot? Say again? The x will always be in the 0 right through there, yes. Yeah, it will always be at 0. It will always be at 0. And so again, they mislead you. They're showing you like, it looks like it's down here, right? But this is the x0 and there's the y0. So this is quadrant 1 and this is quadrant 4 when you're looking at your grids, right? We don't go to negative x's. Okay, residual plot. Everybody good? Beautiful. Residual plot magnifies those deviations. They make them stand out just a little bit better, okay? It's easier to see unusual occurrences. It's easier to see the biggest residual, the smallest residual, okay? Sun's getting ready to come in. So that's why we have residual plots for mainly that right there, just to see those oddballs, those unusual occurrences, okay? And then this is the biggest thing a residual plot will do. That's the biggest thing. It's going to tell me if it's going to tell me if the regression model is appropriate or not. So that's what we're going to talk about in the next slide. But that's what a residual plot does. It magnifies those deviations. It makes it easier to see the unusual occurrences. And then what it's going to do is it's going to basically tell me if a regression model is appropriate or not. Okay? Clicky, clicky, click. The residual plot should know this. I changed this because you guys are too freaking smart. A residual plot should not be curved. How about that? It should not be curved. You guys, most of you guys are really mathematical, so you can almost see a pattern everywhere. So I don't mean to say it needs to not see a pattern, right? Here's what I mean by that. Y'all see that residual plot somewhat? So some students will say, well, that's a pattern. It's not good. No, that's okay. It's not. It does a better job of predicting at the beginning than it does the end, but it's still okay. So residual plots should not be curved. Okay, it shouldn't be curved. They should be small in size, right? Because if they're small in size, that means we're predicting somewhat accurate. So those should be small numbers on the side. What were these over here? Well, they went all the way up to 10,000. But if you guys can remember, those were what, the miles? right? So how many miles we were off. So you could expect those numbers to be fairly large, but they should be small in size. Okay, they shouldn't be just totally outlandish. Okay. Everybody good? Yippee, yippee, yo. Here's an XY. Here's an XY. Y'all see this? Obviously what? Curved. Obviously curved. Okay? There's no doubt. I don't need a residual plot to tell this. But if I find the line of best fit, it's going to go something like that. That would be the line of best fit. So at the beginning, I'm over predicting. In the middle, I'm under predicting. And then I go back to over predicting. That's obviously curved. Okay? Well, when I look at the residual plot, that's what the residual plot looks like. That's telling me for a fact a line was not a good judgment of that data, okay? Because the residual plot has an obvious parabola shape, and you guys can think, hopefully you can somewhat think about that. If it's a parabola shape, I mean, this is the line of best fit, right? That is that line of best fit. It just happened to look like this. And so it's, when you see just this, you ought to know, that original set of data wasn't linear. It wasn't linear. So that's what I mean by a curved pattern, or a pattern to the residual plot. Everybody okay? Good? Okay, so determine if a regression model is appropriate, we're going to look at the residual plot. We'll look at the residual plot. If there's no leftover curved pattern in the residual plot, then the original set of data was linear. We want that residual plot to be scattered. We want positives, we want negatives, we want them throughout the whole thing. Okay, we want it scattered. If the residual plot's scattered, that must mean my original set of data was linear. Okay? Again, you won't have to make residual plots. You just have to look at a residual plot, and they're going to ask you, what does this residual plot tell us? Good, bad, indifferent. Okay? And like I said, you'll have some homework questions to get you thinking about that kind of stuff. Oh, that's what it says. If the leftover curve pattern of the residual plot, consider using a different form of regression model. And that's what we're going to talk about in 3.3. That's what we'll talk about in 3.3. Good? Question? Right now, all you just need to know is what? Linear, or is it curved? Or linear or not linear. How about that? Not really curved, but linear or not linear. Okay. Truck, 38, 25, 7, 16, yada, yada, yada. That's the residual plot. Is a linear model appropriate for that data? Yeah, good. It's scattered. You don't have to make a whole lot of judgment on it. I mean, no, it would, curved is the bad one. A curved line, and it can be positive or negative. Either way, curved, okay? Because there's no obvious pattern left over in the residual plot, a linear model is appropriate. Okay, residual plots, we're good? All right, two more things we got to discuss. So we've talked about residuals. We've talked about R. I think that's pretty much all we've done. Of course, we talked about Y hat, predicted, scatter plots, yada, yada, yada. Now we're going to talk about two more variables. Okay, two more variables. So S is the first one. S is the first one. Y'all remember when I showed you right on that calculator how we go over to that second side because it gives you that S value. I said we're going to use that. Okay. S is the standard deviation of the residuals. Holy cow. You can see me asking about 16 questions from just what that is, right? Because first, now you got to know what standard deviation is, and you got to know what a residual is. What is standard deviation? Average distance from the mean. Well, we're talking about a residual now. So you know what a residual is, right? A residual is the distance from the point to the line. So the standard deviation of the residuals must be the average distance the points are from the line. Good enough? So when you kind of put all that stuff together, I mean, that is what it is. Measures the typical distance, the average distance between the actual and the predicted. So I mean, again, all this stuff that we're kind of learning as we go, we have to start putting some of these things together. If you understand what standard deviation is, then you're pretty close to there, but you got to know what a residual is. And a lot of times, guys, I'm sorry about this, they'll do S sub E a lot of times. Y'all remember we did S of X, right? So they'll do S of Y sometimes. They'll do S of E, and I don't know why they don't do S of R, but they do S of E. So just recognize that. I'll show you where you get it from. Your calculator gives, when you do a ln reg, right, it gives you that little S. That has to be what that is. That's the standard deviation residuals. If you do one variable stats and it gives you the S, that's the standard deviation of the X values. So anyway, S, it's the standard deviation of the residuals. That's the average distance away the points are from the line. So common question, again, a common sense question would be what? We want S to be what? Small or large? We want to be small. Because if it's small, then that means we're predicting it what? Somewhat accurate. Okay? So S. Good? That's not bad. And now R squared. And I hate this variable more than any of them because for me to try to explain to you what that means, it really confuses students. I'll be honest with you. It's not that easy to explain what R squared tells me. So I just tell you what it is and you just memorize the definition and you will never miss a question as long as you memorize the definition. Okay? It is the percent of variability. Remember those words. Oh, it measures the percent of variability. It measures the percent of variability in Y. Of course, I have Y in quotes because we're always going to put Y in context. The percent of variability in Y. That's explained by the LSRL. The LSRL is explaining the percent of variability. And every time you see R squared, or you see the coefficient of determination, this is all going together, R squared, coefficient of determination, percent of variability. All those things have to go together and you have to just link it. And however you got to do that, but you guys are freaking brilliant because I know you are. I've seen it. And so all I'm asking you to do is pretty much memorize that. And if you memorize that, you will never miss a question. I still have a tough time explaining what R squared is. I really do. I have a tough time. I can tell you what I think it is, but don't try to put that ever down. You just always put the percent of variability. Okay? Percent of variability. Now, you guys already know what R is, right? The R gives me what? The strength and direction of a linear relationship. Good? If I square R, I'm going to get this. If I have this and I want R, I just take the square root of it. So they are interchangeable between the two, but this one's a percent and this one's a decimal. This one's a percent and this one's a decimal. This one is the square of this one. So this one will always be positive. That's the question that always gets you, because one question on a test, I'm going to give you what R squared is, and I'm going to ask you what R is. And 99% of students will take the square root of that and give me that number. And 50% of the time, you're right. Because the other 50%, it's negative. How the heck am I supposed to know what it is? Look at the slope, right? If the slope's positive, then this is positive. If the slope's negative, this is negative. You guys remember when you took the square root of something, it's always the plus minus, right? How do we know if it's plus or minus? Well, we know if it's plus minus on this one by the slope of the line. So we have to tie that in together too, okay? So tie that part in together. But it's the percent of variation. I'll go a little bit into it just because of curiosity. I'm going to ask you to predict the price of a house in Bentonville. I'm going to ask you to predict the price of a house in Bentonville. Fair enough? Well, the only thing you have to go off of would be an average. Fair enough? An average, because that's all you have to go off of. So what's the average cost of a house in Bentonville? Well, that's pretty much what I'm going to tell you what the price of a house is. But if I know what the square footage is, that helps determine the price of a house. So that's kind of what R squared is telling me. Because I know what X is, I'm actually predicting it with more accuracy because I know something about it. Yeah. But it's the percent of variation. If you just remember that, you're golden. You're golden. Yippee? Y'all okay? So, S, standard deviating residuals. That makes sense. It's the average deviations from the distance from the y and y hat. Coefficient determination is the percent of variability. Percent of variability in y. Everything's with y. Everything's in y. So if you talk about the percent of variability, there'll be multiple choice questions. Oh, we got R squared. I don't know what that means. I guarantee it. One of them's going to say the percent of variability. Guarantee it. And if it asks you the percent of variability, then you know you're looking for R squared or the coefficient of determination, which is starting to get confusing because what's the other one? It's called the correlation coefficient, right? So they both have coefficient in it. One of them's a correlation coefficient, the other one's a coefficient of determination. Here's how I always remember this. I know this may sound stupid. Correlation coefficient. Yay? That's not R squared because that's C squared. I don't know. That's how I remember it. Makes no sense whatsoever. You would think the correlation coefficient would be R squared because that's C squared, but it's not. So it's just the opposite of what I think. But my brain's weird compared to y'all's, I'm sure. No, it is. It's weird. So that's how I determine the difference between those two. R squared tells us how much better a line squared does at predicting the values of y than simply guessing the mean. But again, percent of variability, percent of variability. All right, so I'm back here at my trucks. I've got S is 5740 and I got R squared is 66. Okay? Again, they're going to tell you this information. They're not going to ask you to find it because a calculator can give it to us really easily. Interpret the value of S. A typical distance the points are from the line is 5740. They probably want the word predicted in there. Good. So the typical distance, the predicted point is away from the actual point. So we can start getting, you can start getting a little bit more tedious with it rather than stating it as broad as you want to try to be as good at, you're trying to get ease. We're trying to get ease. If we don't get ease, we at least want a P. And P would say the typical distance the point is from the line. That would probably be a P because you got the idea. We're just not getting precise enough. Good. The actual price of a Ford is typically varies. So this is what this book always says when we talk about the standard deviation. Typically varies about 57 away from the price predicted by the least squares regression line with X miles driven. Yeah. Right. They got some little bit of context in there. Nobody's going to say it exactly like that, but we just got to get close. Good. Now interpret R squared. 66% of variability in, what was the Y? Miles driven? No, price. Y price. 66% of variability in the price given by the line of price versus miles. 66% of the variability. I'm telling you, if you get that part, you got the P in Y in the price as explained by the least squares regression line or as explained or as accounted for by the LSRL. The line is accounting for that variability. Okay? Told you, bunch of definitions in this chapter. It's one question on the AP exam, typically. But that one question's a difference sometimes, right? It's going to be several questions on this test because we just have a chapter test. All right. You will see at least one of these on your test, and you will see one of these on the AP test. No question. They've showed one of these every year. Okay? This is a regression analysis. So basically, you're punching all this stuff up in your calculator, and you hit enter, right? But statisticians do not use TI to do stuff. They use computers. In fact, they just don't use computers. They don't even use Excel for the most part. They use a program, a statistical program. So here we have a statistical program that they put all the data in and they hit enter and poof, all this stuff came out. Okay? All this stuff came out. So our job is to be able to read this and make sure that we get the information we need from this computerized output. Because sometimes they're going to give us some information and they're going to say, when printed out, it created a blurb and we can't see this number. What is this number? That's like what they like to do. Okay? So, regression analysis, this is exam score versus revision time. Exam score versus revision time. So we know we have an X variable and a Y variable, and one of them's exam time and one of them's revision time, and I'm not too sure which one's which. But at some point in there, I will be able to figure this out. The regression equation is exam score equals 44.5 plus 555 times revision time. So now I know which one the X is, and I know which one the Y is, and guess what they didn't put on the Y? My hat. Okay? So when they ask for the equation line, make sure you put the hat on it. Okay with that? Good? All right, so they gave me the equation line right there. They typically will not give you the equation of the line. They typically say that's what got smudged off. I can't find the equation of the line. You go down here right below this, it says predictor, and right underneath predictor it says constant and it says revision time. Revision time. Constant. COF, which probably stands for coefficient. SE COF, nothing yet. T, nothing yet. P, nothing yet. S, standard deviation of the residuals. RSQ, R squared. Don't ever, 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 ever use that. That says R squared adjusted, which I don't know what it's for because we don't ever use it. Analysis, source, regression, residual errors, total. You'll never use any of this stuff. Chapter 13. When is that? If we get to it, it's the last week. So, at some point on there, you're going to see COF. At some point on any one of these computerized outputs, you'll see COF. And one of those COFs lines up with a constant, and one of those COFs lines up with a variable. Always. Always. Well, the COF and the constant is always your y-intercept. Because if it's a coefficient of a constant, it really doesn't make sense. A coefficient of a constant, because that's what the coefficient is. The coefficient's a number that goes in front of a variable. So the coefficient goes in front of a constant. It doesn't almost make sense. So that's my y-intercept. Okay, that's my y-intercept, wherever that lines up. And then this coef says coef of revision time. That must mean that this is the coefficient for revision time, which in this particular case is my slope. It's always in front of your x. So now I know that x is revision time. Now y, I'm not too sure is, but somewhere they're going to tell me what y is. And I can see that revision time is x, and so the exam score must be the y. Okay? One of your questions on your test, I'm going to give you a computerized printout, and I'm going to say, what is the equation of the line? Or what is the equation of the LSRL? Or something like that, right? And I'm going to get some knucklehead put y equals 44.45 whatever plus 0.555x. And you're probably not going to get any points. I don't know. You might get one. You might get a P for that. But you forgot the hat. And then we got to put it into context. So you forgot hat and context. You forgot two things. If you put the hat, you will get a P, but you still forgot context. So you're going to miss the E. Context, I need to probably say exam score hat equals 44.51 plus 5555 revision time. Okay? Good. Beautiful. And then they may ask, what is the S? And so what is this? S, and S is the standard deviation of the residuals. And then this is the R squared, and there's the R squared. And then they might ask for the correlation coefficient, which is R. So this mathematical, you got to put this into a decimal. Don't take the square root of 72.8 because that number is going to be bigger than 1. And you know R can't be bigger than 1. So turn it to the decimal, take the square root of it, and then look at this to decide on if it's going to be positive or negative, because that's the coefficient of the slope. And if the coefficient of the slope is negative, you know you have a negative sign, and if you got a negative sign, then you got a negative R. Good enough with all that stuff? So if you can read one of these, you're going to do pretty good on one of the free responses. And if you can't, it's going to be really tough because you can't figure out what the equation of the line is. Because the next question is going to say, what is the exam score if you revision time for 20 minutes or whatever it might be? So you're just going to plug and chug into the equation. And then I'm going to say, it is known that the point is, if you revision for 60 minutes, your score is this. What is that residual? So now you got to plug that in the equation. Actually, it's the same number, so you don't have to plug it in again. And then you got to do y minus y hat. And then I'm going to say, here is the residual plot. What does the residual tell us about the line? And basically, you're going to see if it's scattered or not. And if it's scattered, you're going to say a line fit pretty well. And if it wasn't scattered, you say, because the residual plot has a curvature pattern to it, the original set of data was not linear. Boy, you see all that stuff we can ask just off of one question? But it's not that hard, except I've been doing this 15 years. I got it down. You guys got to figure this out between now and next week. So, y-intercept, slope, standard deviation residuals, R squared. Most of the time it all looks exactly like this. This is it's called Minitab. It's a program. So most AP Stats uses Minitab. There's a couple other ones out there, but don't ever use R squared adjusted for anything. Never, just cover it up as soon as you see it. That's nothing for AP Stats. And this SE coef and the T and the P, all that's chapter 13 stuff. We'll use it then. So we still got to remember all this other stuff. Questions? Good? Yes? Okay, so the y-intercept comes from this coef. Will always line up to the constant. So where those two meet at will always be the y-intercept. And then where the coefficient lines up with whatever variable that is will always be the slope. Okay? I didn't figure it out. It gave it to me. Like I did. Somehow or another, we just have to have the data. If this is marked out, I don't know how to, there's no way to find it. They don't mark those out. They don't do this. They don't tell you the equation right here. Okay with that? I mean, if they just told you that, I don't need any of this stuff, except the S and the R squared. Everybody else okay? Good? Computerized print output. There should be some of those on your homework. There should be some of those on your homework. Okay, now, this is probably the only time you'll ever use your formula sheet. Okay, your formula sheet gives you two of these formulas that you're going to need to calculate this answer. Okay, using technology is most often the convenient way to find the equation of the least squares regression line. Excuse me. It's also, good gracious, it's also possible to calculate the equation of the least squares using means and standard deviations of the two variables. So what they're going to end up doing is giving you x bar and y bar and s sub x and s sub y. This is the mean of all the x's. This is the standard deviation of all the x's. This is the mean of the y's, and this is the standard deviation of the y's. Okay? So we already learned that stuff in chapter 1 or chapter 2 or somewhere in there. Okay? So you got a set of x's and you got a set of y's. So we'll find the average and the standard deviation. We'll find the average and the standard deviation. We have that on explanatory variables x and y. Yada, 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 there's that same thing, okay? The least squares regression line is that. We already know this. you already know this is y hat is equal to a plus bx. That's on your formula sheet. If you ever forget it for some stupid reason, that's on your formula sheet. Now, this is the one they put on your formula sheet. They don't put the ax plus b one. Okay? They don't put ax plus b. They put a plus bx. Again, it's not that big of a deal. You guys are brilliant enough to know that a has to be the intercept and b has to be the slope. Okay? The other equation they're going to find on your formula sheet is b is equal to r s sub y over s sub x. Well, the equation I just showed you says y hat is equal to a plus bx. So b is my slope, so that's going to find my slope. Sometimes they might give you the slope and the standard deviations and ask you for r. Okay with that? So just multiply or divide both sides by whatever that is to get r by itself. You might see that sometimes. It's not asked a whole lot, but you might see that. And then another thing they're going to give me is a is equal to y bar minus b x bar. Well, they already told me what x bar is. They told me what y bar is, and they told me what s of x, and they told me what s of y was, and I hope they told me what r was. And if they told me all that, I can find b. And if I can find b, and I know this, and I know this, then I can find a. Those equations are on your formula sheet, so you don't have to have them memorized. They're on your formula sheet. So it's one of the few times you're going to need your formula sheet because you won't remember those. Okay? What I do is I don't want to give you the whole formula sheet because that's just, to me, that's, I mean, I will, I don't care, but I just put those formulas on the test. They're up there in the top somewhere. I'll give you the whole formula sheet if you want it, but I just put those on the test for you. Good enough? Question? Y'all okay? So they're going to give you enough information to be able to use those formulas. You just got to remember, oh, these are the ones I need the formulas for. That's the hardest part. Like, what am I supposed to do with all this? Those are the formulas that they got to have, okay? Correlation, regression, Oh, I remember this. Looky. Good? Scatter plot? X, Y's? Moderate, strong, positive, linear association? Good? Ooh. Moderately strong, positive, curved. Same numbers at the bottom. Same numbers on the bottom and the side. Beautiful? Look at this jacked up one. It's beautiful except for that one stupid point way up there. Look at this jacked up one. Beautiful? Y'all see all four of those? You know what's really, really interesting about all four of those? They're all for the exact same equation, and they're all for the exact same R. All four of them are the exact same equation of a line of best fit, and they're all for exactly the same R value. All four of them. So what does that tell you? R and the equation doesn't tell me anything about a line. Good? R is 0.81. So you can say there is a moderately strong or whatever word you want to use, positive correlation, linear correlation. You could say that for all four of those because that's what R tells us. However, when I look at that, I'm not predicting it very well. I'm not predicting it very well on any of them. Okay with that? Keep that in mind. I don't care what they tell you R is. I don't care what they tell you the equation is. It really doesn't tell you anything about the data. You need to take everything into account. You need to take S, you need to take R squared, you need to take R, you need to take the equation, and you really need to take the residual plot. The residual plot's going to tell you the best, right? This residual plot's the only one that's going to be scattered. That's the only one that's going to be scattered. This one for sure is going to have, this is my line of best fit, so it's going to have some negatives, then some positives, then some negatives. This residual plot's going to look something like this. Okay, so you'll have some positives, then some negatives, then some positives, and then one way out of the way. And then this one is going to kind of go like this, where you're going to have a whole bunch of residuals right here at 8, a whole bunch of residuals right there at 8, and then you're going to have one residual way out here at whatever that number is. Good? Just kind of take all into that account. Correlation regression lines only measure linear relationships. We've talked about that. Okay, so let's talk about these 3 things. I hate to. Let's forget that word. More students miss on the test because they use this word and they're looking for a different word. So let's don't even talk about this word. Let's don't even talk about that word, because the other 2 words will take care of that word, but if you use that word on the test, you don't get any points. They're looking for one of the other 2 words. Y'all hear what I'm saying? So the other 2 words I'm getting ready to give you take care of this word, and this word is only this book. I've never seen it before. So outlier. Outlier is a point that has a really high residual. Outlier is a point that has a really high residual. A high residual. So you can really only see an outlier one of 2 places, I guess from the scatter plot or from the residual plot. A really high residual. Most of the time an outlier is mixed in with a bunch. We'll pull you an example up here in a second. It's mixed in with a data, it's just really high or really low. It's mixed in with the data. This high leverage one is one that's not really mixed in with the data. It's one that's way out. But they want to call it something else other than high leverage. They want to call it an influential point. Influential doesn't necessarily have a high residual, but it's really influential. It's really influential. It substantially, boy, that's a big word, isn't it? Changes the slope or the intercept and the core. It just changes those values that we've been looking at really, really, really much. A lot. Let me back up real quick and I'll put this back up there because I know you guys are looking at it. That is not necessarily an outlier because my line is going to go somewhat like this. That's not a really big reason. However, it's very, very influential, right? It's changing the line from doing this all the way over to here. If you guys remember my little points I was putting, right? And when I dragged one and put it way down here, I made the data go from this to that. That's really, really influential. Really influential, okay? It's a, what was that other word that they used? High leverage, right? It really has an effect on it. So an influential point is really anything that if I remove that point, it substantially is going to change the slope or the y-intercept or the correlation. It's going to change, and it doesn't have to change all of them, but it's just going to change it quite a bit. Quite a bit. In other words, it has a large residual also, but let's go back. Let's see. I don't have an outlier on any of these. If this point here was more here, it's an outlier because if I remove it, it's not substantially going to change that. It's just kind of really going to move it down, up or down just a little bit. Maybe just a little bit, not much. And even there, it's not going to do a whole lot. I mean, it's not fitting the data very good. Okay, so some of these it could be considered both. The one on the test is not. I mean, it's obvious. It's obvious. Okay, so an outlier is one that has a large residual. An influential point's one that's affecting the line a whole lot. Okay. Beautiful. Y'all good? Y'all see this data here? Child 18 is very, very influential. Go back one more. I'm not done. Okay, good. I'm sorry. Sorry, y'all were still writing. Influential and outlier. And truth be told, I don't think I've seen that separated that much on AP. Like, I haven't seen you say the wrong one. I don't think there's such thing as a wrong one or a right one. Truth be told, on AP. However, high leverage is not used. Could be considered an outlier or influential. We're smarter than that. We can tell the difference. So I think we should be able to tell the difference. Okay, good. Still a couple writers. They're both writers. None of them are lefters. Writers, lefters. No. Huh? Right-handed? Yeah, writers. No, they're lefters. Some people are just now getting it. Okay. Age at which the first words were and whatever this Gosnell score was. Beautiful. Slopey, slope, slope. Child 19's way up here. Child 19's an outlier. It's with the data, it's just kind of high. Child 18 is high leverage. It's not really a big residual, but it has a huge effect on that line. Very influential. Not high leverage. Did I say it backwards? Shucks! Good catch. First mistake this year. Did I make one yesterday? I did make one yesterday. That was last year. Oh yeah, I restarted. This year just started. I only make one mistake a year. Last year I made a whole bunch. This year I'm only going to make one. Just started. Just made it. I didn't say when I was going to start it. I hope, guys, you can make predictions using regression lines. Of course, you already did that on the first part of the homework. I hope you can calculate and interpret what a residual is. I hope that you can interpret the slope and the y-intercept. There's a lot of interpretations, right? Interpretate R squared, slope, y-intercept, S. There's a whole lot of interpretations on this chapter, okay? Determine the equation of the least squares regression line using technology or using a computerized printer output. I hope that you construct and interpret a residual plot. Assess whether the regression line is appropriate or not, okay? I hope that you can interpret the standard deviation of the residuals, R squared, the percent of variation, and use these values to assess how well a least squares regression line fits. You should be able to go from all these, right? We want R to be close to 1 or negative 1. That's what we want. We would like it to be strong. We want S to be a small number, right? We want S to be a small number. Well, if we want R to be close to 1 or negative 1, then we want R squared to be close to 100%. Because if you square 1, you still get 1, and that's 100%. So if you square 9, you get 0.81, that's 81%. Right? So we want R squared to be somewhat high, closer to 1 also, or 100% if you want to. And we want the residual plot to be somewhat scattered, right? We're looking at all those things. Describe how the least squares regression line, the standard deviation of the residuals are all influenced by an unusual point. It's either going to increase the slope, decrease the slope, increase R, decrease R. If it increases R, it's going to increase R squared. Find the slope and the y-intercept from, let's see, oh, that's right, using those equations, okay? Boom, 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 boom. What time is it? 8:13. I got done quicker than I thought.